Hi everyone, welcome back to Dragonfly Engineering. So this week we've got more of a technical discussion regarding configuring the KUKA Robot controller, which controls this big yellow KUKA robot here. And more specifically to configure the input and output module so that this robot can talk to the outside world and it can affect the outside world. So it needs to receive input signals to act on and also output signals. In this particular case, 24-volt digital input signal and 24-volt digital output signal. And this is done with a Beckhoff IO module. So in this episode, I'm going to show how I install and configure the IO module so that this robot can actually work with the outside world. And a lot of it was self-taught, probably the least efficient way of just frustrating trial and error. But I wanted to also make this video so that I have a reference to myself the next time I need to configure a robot with different IO modules or other features. Then I have like a record for myself. But I figured this would be useful for everyone else out there who may have bought like a KUKA robot on eBay or whatever, and they can't get it can't get it to talk to the outside world. This little tutorial should help. So it's a little technical. You all might not enjoy or want to watch it, but for those who really need this information, hopefully it's helpful. Oh, and also there's also a new addition to the robot family here. This little Epson robot is a new robot purchase, and April and I have been working together on that. She's actually pretty much is the main owner of this robot. She's figured out the controls for it and some of the basic programming like if-then statements. So this robot is kind of nice because it can do a lot of decision making, sorting parts and pass-fail of parts and things like that. The KUKAs can also do that, but I'm not very versed in the KUKA code to do all of that high-level kind of Python scripting that is more intuitive with the Epson robot. So there's going to be future episodes about this Epson robot as well. Oh, and this is a KUKA KRC4 controller. This is one with the orange. There may be a more modern controller now, but this is one of the latest controllers that they have. And then we'll watch the pendant here, and basically it's waking up, it's asking if there's a robot attached to it, and it's looking for EitherCat and other things. And everything you see here is normal. When you see 3 greens, that's a good sign that it knows that there's a robot there. Oh, and then we'll turn the switch. And it's looking for the serial number of the robot. And it says it found the control board on the robot and then the serial number. Alrighty, and then we can switch back. Now you see here it says sysx44, error during ECAT stack initialization. That's in the warning. We'll confirm that, but it doesn't go away. And the reason why we see this error is because our EitherCat was powered down. See, we got no power on it right now. So if I flip the circuit breaker and turn on our 24-volt power supply, you'll start to see internet activity or Ethernet activity in the connector down there and then on the EK1100 as well. Now if we go inside to the X44, you can see the X44 connector, which is this EtherCat, and the card is labeled itself right there. You see that X44? And we have active Ethernet activity on that port. So that means that this robot controller is talking to the EtherCat controller up here, the Beckoff EX1100. But since we started the robot up, oh, actually no, it recognized the bus that the EtherCat is talking to, and the error went away. So that's interesting. Let's see if we can actually activate the axes. And we can. So right now A1 is lit up and the robot should move. And it does. It's just very slow because I'm in teach mode right now. Alright, that's a good sign. Alright, so as we zoom in here, actually we can just go over the overview. So these big white power packs are some of the main drive power packs for these stepper motors in the robot itself. You know, so like this is one of the stepper motors, and then we got more stepper motors, and then really big stepper motors down here. And this is the biggest, which is the main A1 axis. So these stepper motors, you know, power and encoder go through a big cable in the floor over to the KUKA. And these are the motor drivers, and I think I want to say there's probably three motor drivers per pack, because this is a 6-axis robot, so we got 1, 2, 3, 4, 5, 6. And this one, I'm not sure exactly what this one is here for, actually, but it must do something, I don't know. And then over here is kind of the communications board, and like I pointed out, the X44 is the most important one regarding the I/O module. Some other things of interest: the main computer is in this industrial cabinet, and this is an Ethernet switch, which is handy to talk to the Ethernet network in here, so that you can actually configure the Ethernet communication board, and specifically the X44 connector, to work with the Beckhoff module. So now we're going to talk about that next. So let's do that. This Beckhoff IO module is what is used for the robot controller to read digital inputs or analog inputs from the outside world and then act upon those, or to send out 24 volt, in this case 24 volt output voltages to control things like its gripper, or to trigger other robots to do something. So without the Beckhoff IO module of some sort, your robot is pretty limited, unless you have like you purchase like a gripper package from KUKA, which I don't recommend. You can just buy a gripper from the internet. I think I got this from Plastic Processing Equipment, and you know, with this gripper, which I want to say was $100, and a $30 pneumatic valve that's powered by 24 volts from your Beckhoff controller, you can have your robot pick and place stuff all day long. And of course, the inputs are needed too. For instance, if the robot is looking at a conveyor belt with a laser beam across it, and when the laser beam breaks, your input signal will go to the robot to tell the robot to activate the gripper to pick up the part off your conveyor, as one example. So you really need to have this Beckhoff IO module configured with your KUKA robot for you to do anything. And we can zoom in here so I can show you in more detail. Let me do that now. So this is the Beckhoff system, and the first module, which is the base module that the Ethernet connects to, is the EK1100. So this is kind of the bus that supports the digital output and input modules. And I've got this sped up to 2x speed, by the way. So you connect your EtherCat or Ethernet connection to the left, and then it's powered by this 24 volt power supply, which is conveniently next to it. You hook up the power to the inputs, or the main of the Beckhoff EK1100, and then each module is stackable, and you can add more modules onto the end of this daisy chaining of input or output modules by lifting up this orange kind of release tab, and then effectively you can just stack more of the modules onto the the DIN rail that is mounted to your cabinet. So here, this is the DIN rail, which I had to disconnect so that I could actually remove the bad input module, which was labeled D11. Here you can see it's D12, and those are just labels that were added by the previous owner. So this is the bad module, and I can show you how these connect. So on the side, there's some gold contacts that create a data bus, and then so you can see at the bottom there's an array of like spring contacts, and those all connect when you slide this module onto the array. So those. And then these are power tabs, I believe, like 24-volt power tabs, which are like tinned metal. And then this component actually slides on with a couple of plastic rails that kind of lock all of these components together when you slide it. So here I'm lining up the rails. I pull up the little ejector tab there, which frees up the snap at the bottom. And then that module snaps onto the DIN rail, like you can see there. And then you push that little orange tab down. Supposedly it locks the plastic snap so the device won't come back off. And then you can add more components if you want with those little gold-plated spring connections. Now, to remove the device, you pull up that orange thing, but I can't get these modules to snap back off the DIN rail. So if somebody knows the trick to get those off, short of lifting up the entire DIN rail and sliding the whole stack off so you can get the one on the end off, I'd like to hear about it. So if you can comment below, that'd be great to hear. But yeah, so those just snap in, and you just stack them as many as you want. Now, if you put too many of these modules onto the EK1100, I believe you have to supply additional power lines to multiple 24-volt inputs. So there's like the red labeled and the blue labeled contacts. And I think I was trying to figure out my wiring here, but if you have too many modules and some of the ones on the end don't work or aren't registered by the robot, then you have to add jumper wires to the supplemental power ports below. Okay, so let's turn on the robot and we'll see how all of this talks. It's going to get a little noisy too. The integrator who actually set it up with a lot more components than what I needed. So I stripped a lot of that off, and it was all resident in like a sub panel that would be on the wall next to this robot controller. But they did put an Ethernet switch in here, or a hub, and I found that it's easiest to hook the Ethernet connection between your PC, like a Windows PC that you're going to use to configure the robot. You just connect Ethernet from your PC, in my case, to the switch. But if you don't have the switch, then you can find a connection on the controller itself, an Ethernet plug, and basically find the one that your computer can talk to, and the software that configures this system, which is called WorkVisual. In this case, it's WorkVisual 4, can actually talk to the robot controller and download the configuration onto a virtual or a WorkVisual screen. And then you can reconfigure your robot through the Windows PC, talking with this Ethernet connection. So you may not have a switch here, an Ethernet hub, but you may have your Beckhoff module, your I/O module, mounted inside of the cabinet somewhere, probably in this area right here. So we're going to plug in our Ethernet cable. To one of these hub locations, and I can see that there's Ethernet activity on the cable now. So now we're going to go over to the PC and start up WorkVisual 4.0 and dial into this controller and download its configuration. All right, so I'm out here at a kind of a junky ancient lab computer, so it's going to run slow because it's Windows. It's more than 2 years old. So we've got WorkVisual 4, and WorkVisual 4 is the version of WorkVisual that talks to this particular era of KUKA controller. So you have to match your WorkVisual version to the range of software versions that's on your KUKA controller. So for instance, WorkVisual 5 will not talk to this controller, neither will WorkVisual 6. But WorkVisual 4 won't talk to one of my smaller Agilus robots with the KUKA KRC4 Compact, which is a much newer software seat or a new robot. So you pretty much, if you can't connect, you got to keep going up or down the versions of WorkVisual until you can actually connect to your robot. So let me click on WorkVisual here and we'll open it up. And the Ethernet is connected between that hub and the KUKA controller over there and this Dell PC. And I saw that there was activity on the line. Just looking at the flashy green light in the back. And again, this is going to take a while because this is an old PC. Eventually, you're going to see this WorkVisual Projects Explorer. And it's kind of a file explorer of the projects that you've worked on before, which are just different configurations for different robots or multiple configurations for the same robot. So if you want to pull the active configuration or the kind of the instruction set off of your robot that you've hooked up to the Ethernet connection, then you can go to this Browse button down here, or you can open an existing one that's saved on the PC and then reload one that's saved on your PC. So this is a good way to back up your configuration. You can have it saved on your WorkVisual program on a PC and then reload it in the future if you have some issue, like I did. So, but what we're going to do is we're going to download the active project that's on the KUKA controller by clicking on the Browse button. And again, if your WorkVisual version doesn't talk nicely to the software version of your robot controller, you got to find the one that does talk. Otherwise, you'll just see no cells here in the window. But since we did see that something popped up, that means that our Ethernet is talking, and we just downloaded the active configuration from the KUKA robot itself. So you can click down, and again, this PC is slow. So like for instance, that's the name of the controller, and then that's the Ethernet address that it's talking to right now. Okay, there we go. And then these are all of the projects that I think are resident on the robot controller itself. But we've got one called Dragonfly Fixed IO. The little green indicator there means that this is the active project. So we're going to click on this one, and we are going to say open over here. And what it's going to do is it's going to download that active project off of the robot controller. There's a progress bar down here, and again, this PC is super slow. And then we will have the project loaded onto WorkVisual on this PC. Okay. And it shows like a configuration map, which is basically just a controller and the robot. So what I'm going to do is I'm going to save this configuration to the USB stick that I got here in my hand. Save it to E, I think, is the USB drive. And we'll just give it today's date. I'm in the US, so the naming convention is different than the Europeans. Okay, and save. So right now we're saving the robot's configuration that we just pulled off the robot to a USB stick. And what I'm going to do is move to another computer that has a screen capture and is in a quiet area of the shop, and then we can work on this robot configuration on a different computer that also has WorkVisual 4.0. If you want to get WorkVisual 4.0 or 5.0 or 6.0, then you can download it from the KUKA downloads portion of their website online. Okay, let's go to the quieter area, and I'll take this stick with me. And what I'm going to do is I've inserted the USB, and I'm going to load the project that we saved on the other computer that we downloaded from the robot. And we're going to go to the USB stick here and open the file that we just saved. Now, we're going to probably get some errors because we're not actually connected to the robot controller. So that's what that stuff down there is. And we'll just skip that for now. So what you want to do when you open this project is you need to basically double click on the icon of your robot controller and the design tree on the left of the user interface. So here I double clicked and you see the program is loading and configuring the project after you opened up the controller, the kind of the virtual controller. And again, we get some more errors over there, but I think that's just because we don't actually have a controller connected to the WorkVisual right now, but I could be wrong. I'm not an expert in this. So the next step is to head over to the design tree. We can drag it out, and then we can look at the components inside. So you can see we've got the controller, which is the main component, and then the robot is connected. And then below that are a few of the internal bus systems in the controller itself. So here you can see how we are opening up one of the buses that has like the servo packs in it. And then if we look down to the expansion bus, which is what we're interested in, there's a sys or a sys44 sub Ethernet bus. Okay, so in this expansion bus, the sysx44 bus, which is that board that we saw on the side of the controller, within that bus is the EitherCat communication protocol, and that's a subcomponent under the sysx44 bus. So you can click on the EitherCat protocol, and then within that you see the Beckoff EK1100 EitherCat, which is what they call a coupler, I guess, with 2 amp capacity. And then if you click on that, which is yet another bus protocol that's under the sysx44, is the actual modules, the I/O modules that we installed in the previous clip. So here you can see there's 2 output modules, 8 channels each, and then there is the input module, which we only have one of those because there's 16 channels. So you can read 24 volts input, or you can output, I think it's 24 volts and 0.5 amps over those 2 output channels. And then again, that's the input device there. Now this is the one that was bad and that I had to replace. So I'm going to click on this device here, and we can look at the characteristics of it, you know, like its address and a few other things. And then here you can see how the outputs of that particular module are mapped to the internal system inputs and outputs of the KUKA control. And then over here, similarly, you can look at the output device, one of the output devices, and it'll kind of tell you the same kind of stuff. And then so now what we want to do is delete this particular input. But before we delete this input, what we need to do is capture the driver information for that Beckoff module. So what you can do here is you can click on functions and then export. And then here we want to export the XML file, which is the driver that defines to the KUKA software how to actually talk with that Beckoff input module. So I said go ahead and export to a file, and we save that file. And then here, just for good measure, we're going to export the output module as well. But I believe these XML files, or I know these XML files actually contain drivers for a whole family of Beckoff products. But just to be safe, we're going to go ahead and export that one as well. And now we're going to delete this module, again, because this one is tied to a module that failed in the robot. And then now what we need to do is, and actually, so when we deleted that input module, a lot of internal software connections were broken. So those are all the errors you see at the bottom there. Is basically input 1 through 7, which was the original mapping, are all broken now for the internal channels of the software system to the mapped channels for that input module that we just deleted. All right, so we still have the EL2008 output modules configured, but we need to reinstall the input module. So to do that, you can go to the DTM catalog manager, and if you open the catalog manager, it's going to tell you can't actually add anything to the catalog, which is just a list of things that you can add to the configuration of your controller. It's this thing with WorkVisual. If you actually want to install something into your catalog, you actually have to close your project first and then open WorkVisual without your project open, and then install the driver that we just exported from WorkVisual. Again, the driver for the input module. So we are going to say OK to that. And then here you can see our DTM catalog has nothing. I'm not sure what DTM stands for, but it's basically icons and drivers to install everything on your controller with. So what we need to do now is, we need to close out this current project. So we're going to close now, and yeah, we'll save the changes. And when that closes, we can now go to extras and then DTM manager, and then here's the interface for that. And what we're going to do is search the system for any of the DTM catalog components. And again, these are drivers for all the bits and pieces of your KUKA controller or your robot, like servo packs or system X44 expansion modules. So here's all the stuff that we can actually stick on in our KUKA robot. A lot of this is not applicable to us, or it's already installed. For instance, there's the KUKA extension bus, but I'm going to click on just move everything over so that we don't have to pick and choose. And that's what that double arrow means. It means just move it all over. So now our DTM catalog is populated with everything except for, I think, the Beckoff XML driver for that third-party I/O module that we just uninstalled in the previous session of WorkVisual. So here we can kind of scroll down and look for that Beckoff module, the 1809 module, but we don't see it in there. So because there's an additional step that we have to do, if you do not see your component in the kind of the predetermined list that's in the KUKA environment that we're kind of scrolling through here. So that cabinet interface board is kind of the main board that the auxiliary interface boards connect to, like the Sys X44, like this one right here. So we're going to hit OK on this, and now what we need to do is import that Beckoff driver software that we exported in the previous session. And there's yet another way to do that. And what we're going to do is go to File and then Import or Export after we've closed out the session that we were in. So now what we need to do is search for the proper action to import that Beckhoff IO module XML driver file. And you need to find import device description file, which is another way for them to say the XML driver for the input module that we're interested in. So we're going to click next. And now we're going to look for where we saved the XML file that we exported from the design tree. And here I'm clicking on EitherCat ESI.xml file. You want to make sure you don't click on the other XML, but you want the EitherCat one. So it said OK, and I clicked next, and then this is all of the devices that were packed into that XML file, and there's a lot of them. So even though we said just export the EL1809, all of the rest of these drivers are embedded in that single XML file. So there's lots of them: input, output channel, like 4-channel outputs, or 8-channel, or negative output channels, or inputs. So all of them are kind of packed in there. The nice thing is that since we pulled this off of the device that we know that we have in hand, the revision level of these drivers should match the device because it was installed and working before. If you need to get your one off the internet, you'll have to download it from the supplier like Beckoff. If, for instance, you were buying new components, you can download this XML file and then do the same operation. So here we are adding this driver to the DTM catalog, and it kind of automatically did this. So here we'll just hit close. And now we will reopen our project since we've had to close our project to update the DTM catalog. So here you got to double click on the robot controller again to see all of the, this is sort of a preview until you double click on the robot controller, and then it actually opens your robot controller. And that took me weeks to figure out. And then we're getting back into our architecture, so we can click down through the sys x44 down to the eBus. Now we're going over to the catalogs page. You have to drag it over. So over here in the catalog section, you can select all sorts of different components. You know, you can click the entire KUKA Robot controller or the KRC4 compact. This is for the larger system architectures. And then within the controllers, you can like stick like KUKA power packs, you know, those big white ones that we were looking at in the cabinet earlier. But since all of that's already installed on our system, we don't really need to mess with it, and we don't want to kind of scramble it if it's unnecessary. But we're interested in the DTM catalog since we already have all the rest of the KUKA controller configured. In the DTM, you can now see that our recently installed drivers for the input device that we exported in the previous session exists in this catalog now. So now we're just going to scroll through all of the ones that we just imported and find our device, which is the EL180916 channel. And there's two of them there, so I just assume that to pick the top one, and you just drag it over to your design tree, and you can pick where you want to stick it. But ideally, the EitherCat or the Beckhoff input module is connected to the EK1100 sub bus, or the Beckhoff control bus, or that brick of controller. So we're going to basically put the input module at the end of the stack, and that may matter actually, because we've got two output units stacked in, and then the final one on the stack is this input device, the EL1809. So I'm pretty sure that you want to keep the string of devices as it's shown in the design tree to match physically the stack up on the physical stack of the devices. So now we're looking at the I/O mapping, because we actually broke the connections when we took out that other EL1809. So what we have to do is reassign the inputs, the digital inputs, because you can also do analog inputs and outputs, digital inputs and outputs. But for our input module, we are interested in digital inputs. So under the KRC1 IOs, which is the tab at the top that we chose to look at the system inputs and outputs, you can see how in the software system there's input 1 with the $sign all the way up to like 4,000 of them. So the KUKA robot could actually conceivably work with 4,000 inputs, and that little $sign in bracket 1 means that's what it calls its internal input. So right now the software has inputs, but it's not connected to anything. So what we have to do is connect the inputs for the software to the inputs on the device on the field bus, which we just installed on the EitherCat field bus. So if you look at the EK1100 EitherCat folder, the final device that we just put in is the input module. And you can see here the input module has input channels as well, but the input module doesn't know where to send these because we haven't actually connected them to the software IOs yet. So the left side is the software of the KUKA robot, and the right side is the software of the field bus. And what you want to do is connect channel 1 of the field bus EL1809 module to the inputs of the system software. And here you can see by clicking the little connect button, I've connected channel 1 of the EL1809 to channel 1 of the robot IO input system, or input labels for the IO system in the software of the robot itself. So now we're just going to click channel 2 of the Beckoff and connect it to channel 2 of the robot by clicking, or actually we could actually assign channel 2 to channel 5 of the input to the robot system, but it makes more sense to just call channel 2 of the Beckoff is connected to channel 2 of the KUKA software system. So we're not going to click on 5, but on 2, and then we'll click on the connect icon at the bottom center of this section, that guy right there, and then we'll just do that for all of them. It's because we got 16 inputs on the Beckoff. We just tied those to the 16 inputs on the software system for the KUKA, and then when we're out of 16 channels, we can't connect anything else. So there we go. All 16 Beckoff input channels are now connected to the system. So what we want to do now is actually configure in machine language terms that the Beckoff inputs are connected to the software inputs for the KUKA system. And because if we don't conclude this operation, then by doing a code generation, then we won't actually have anything connected to the KUKA software. So we're going to click on generate code, and what's going to happen is behind the scenes in machine language, the software is going to figure out all of the Ethernet connections to connect channel 1 of the EitherCat to the channel 1 of the software itself. And then down at the bottom, you can check to see if there's errors. And I think these are all old errors because the date is later than the current date. And I was looking around how to clear the errors. I think I found it. I think I right-click somewhere in the work area. Yeah, and clear all. Okay, so when we generated the code, we didn't have any new errors. So I'm going to generate the code again just to make sure that there's no errors and we don't see any errors pop up, which is a really good sign. That means that basically WorkVisual understood the instructions that we told it on how to map the inputs and outputs, because the outputs are still there as well. We just haven't changed those with the EL208. So now what we're going to do is basically save this configuration file onto the USB stick, and we're going to rename it. I think I renamed it already. And then we're going to take this project back over to the actual computer that's connected to the robot. Now I'm back over at the lab computer next to the kind of noisy robot controller over there, and we will now import or open up our project from our USB stick, which I stuck in the computer. So open projects, and then we can navigate to the USB, and then here is the saved project from the other computer with WorkVisual 4.0 on it. So we're going to open this. Probably won't hurt for us to generate code again, but let's just double click to make sure that we got everything that we wanted. Oh yeah, you got to click on the robot controller to open up all this useful information. I guess this is just a preview until you actually open it, and this computer is much slower, of course. All right, so there's all the goodies. Here's our EitherCat bus, the driver block, and then our 3 components. And this is the one that we uninstalled and then reinstalled and then created code for. So we're going to generate code again just to make sure that we're still good. And I don't see any error window pop up. So that's good to see. So what we're going to do now is deploy this software or this project to the robot controller, and it will by default become the active project. So one of the first things we want to do, it's helpful to to actually log in to your robot through the teach pendant as a administrator. So you go to configurations. Yeah, so you hit the robot button, and under configurations you click user group, and then you'll click administrator, and then you log in, and the default KUKA password is KUKA, and enter. And here it says we've switched from operator to administrator, and that allows you to import a new program or a new configuration into your robot controller without having to stop, and it'll tell you you need to log in as administrator first. If you want to see what your current project is on your robot, you can click on this WorkVisual icon here on your teach pendant, and it'll tell you currently your project is Dragonfly Fixed IO 1/12/2023, which is the one that we downloaded off the robot and then copied and called our new one. So we're going to deploy this new project where we took away the input module and then added it back and then remapped. So let's do that. I don't have a screen capture on this computer, but we're going to click on this deploy button, and it's going to ask some questions. You want to deploy to this controller? Yes. And it regenerates the code again to make sure everything's fine, so you're not sending errors to your robot controller. And when it says code generation complete, you click next, and now it's going to actually upload using the Ethernet cable your project onto the robot controller. And then at this point you're going to start to see it say waiting for user input. Oh, after we click next. So now it's going to activate the project, and you'll see on our teach pendant it says, do you want to activate this project? Now if we didn't log in as administrator, the computer would say you don't have rights to do this. So always log in as administrator first, and we're going to say yes, and it'll say saving current project, and you'll kind of get information from both screens, the computer screen and the teach pendant is telling you that things are happening. So, like it's building a new modification list, and then here it's going to say, you know, how many changes to the safety changes are occurring, changes to the sys x44 extension bus, machine data, and do you want to continue? Yes. And then reconfiguration in process. And then here the screen saying, oh, it's already activated, so finish. So the PC is basically done talking to the robot controller, and now we're just kind of working with this. And it's going to restart the controller, so it's telling you the emergency stop doesn't work right now. And it's going to show a new safety configuration and ask you to confirm that you agree with all the changes. It may take a little time to reconfigure, but all the work now is happening on the robot controller, and then you'll see how it restarts. And it's done. Confirm. I've got a program with some errors in it, but we don't see anything that says system 44 communication error or EitherCat missing or anything, so that's a good sign. So, oh, maybe you couldn't see that because of the glare. So I am going to hit the robot button again, and then I'm going to click on display. Whoops. Inputs and outputs. Oh, that was actual position. So I'll click the robot again. It's a little tricky to do this while holding. And then display inputs and outputs, digital I/O, and then inputs. So the fact that it shows that it's looking for inputs is also a good sign that we've mapped the inputs correctly, because if we didn't map inputs at all, then I don't think we'd even see this screen because there's no inputs to go anywhere. So let's walk over to the I/O module and see if we can turn this light on by putting 24 volts on input 1. All right, so I'm back over at the robot controller with our homemade I/O module. Again, there's inputs and outputs, 24 volts and ground. So we're going to test input 1. So I'm going to attach a banana plug or a jumper from the 24 volts, which is just using the 24 volt power supply that's powering the module. And we'll stick this into input 1. And you can see that our indicator light is on, which that's just a indicator that there's voltage on that line. But when we look at our controller, you can hopefully see that there is a green dot on input 1. So when I unplug the 24 volts, the green dot goes away. So we successfully reconfigured our robot controller with the input module for the Beckoff input-output system. And let's try that again. So I'll put 24 volts back on input 1. And you can see this green dot here means that we just told the robot, the outside world just told the robot to start doing whatever it's programmed to do. And then you can see we got our indicator light here as well. So that's cool. Now if we go to output, and again, we didn't reconfigure these outputs, but they were configured previously. So if I hold down the panic button, and because we're in teach mode right now, and I click on output 1, and then I tell it value, then it just turned on output 1 right there. So when I turn it off, oh, I guess I shouldn't block it. Let's see here. So now when I turn it off, value, whoops, then output 1 turns off, and then back on again. So now we can talk to the world and we can listen to the world, and our robot will behave based on these inputs and outputs that we see here on the teach pendant. And then you program your program to wait for inputs or put out outputs when you tell it to output to channel 1, 24 volts, which will turn on a gripper or some other thing. So now if you look at our Beckhoff module, we still have output 1 is on. And let's see if I can trigger input 1. There we go. I didn't have a good connection. I'm kind of using the back of these connectors. But yeah, so there's input 1, there's input 2, input 3, input 4. So yeah, we are good to go. Now this robot can talk to the world, and the world can talk to the robot. So there we go. That is how you configure your Beckhoff IO module for a KUKA robot on the KRC4 or the KRC4 Compact. Well, hopefully you guys found that informative. A couple of takeaway thoughts are that if you change your configuration for your robot too much, for instance, the safety configuration is affected, then when you deploy your new project, you may get what's called a safety checksum error. And that basically means the controller's telling you that something about the safety system or the configuration of the safety network and computer is different. And it'll ask you to tell it what you did to make it different. And usually you just say, deploy new project or something like that, or reinstall hard drive, that kind of stuff. And once you answer that question, then it says, okay, I accept your answer, and then it'll allow you to use the new project with the I/O modules or whatever else you changed in your project. So keep that in mind. A lot of times you will have that safety checksum error confirmation that the robot wants to know to keep you safe. All right, well, thank you for watching, and I'll see you guys next week.